Okay, this is section 4.6. We're going to be analyzing quadratics of the form y equal ax squared plus bx plus c. There's a big picture here. Yes! Yes! This formula, we've been talking about it for a while. Finally going to formalize it, so if you know the two x-intercepts, you can find the x value of the vertex. So x value of vertex, that's right, Nico. You can find it simply by doing the sum of those two x-intercepts. That will give you, after dividing by 2, that will give you the x value of the vertex. Alright, let's do example 1. Let it focus. So this one here is asking us to identify the intercepts, the axis of symmetry, and the coordinates of the vertex. So, typical standard fare question. In the last unit we saw questions like this before. If we're going to factor it, we're going to want to pull out this 0.5. So if you're going to pull out the 0.5, you're actually going to be multiplying everything by 1 over 0.5. Okay, you're going to be multiplying everything by that. So out in front, you're going to be pulling out the 0.5. So when you multiply 0.5 by 1 over 0.5, you're just going to get x squared. When you go 1.5 times this, if you think about it, really all you're doing is you're saying how many times does 0.5 go into 1.5. So that's going to be 3 times, so you're going to get negative 3x. And then how many times does a half go into 5? Well, it's going to go in 10 times, so you're going to get that. Now you can think about factoring this bad boy. So it's just a standard factoring question. A is equal to 1, so you're looking for two numbers that multiply to the c term, which is going to be negative 10, and going to add up to negative 3. Looks like those two numbers are going to be probably 5 and 2. Those multiply out to 10. Now I'm just going to focus on getting my signs. Probably if I wanted to add up to negative 3, you're going to need it to be negative 5 and positive 2. So now I can rewrite. So you're going to rewrite x minus 5, x plus 2. Oh, Nico, I know that's exciting. He's crying, he loves math. Now that you have it like this, you can go ahead and you can solve for your x-intercepts, because that is one of the things they want us to figure out. So you're going to use zero product property. You're going to go x minus 5 equals 0, x plus 2 equals 0. You're going to get x equal minus 2 and x equal 5. So those are going to be the x-intercepts. While I'm doing the intercepts, I might as well go ahead and figure out my y-intercept. So that means x is going to equal 0. So I'm going to go back to my factored equation. I'm going to go back to this one here. Nico, you don't like that, buddy? He's like, who cares about the factored equation? So I'm going to plug in x equals 0. Oh, buddy, let me give you a soothie. I'll be right back. Okay, all better. We're back. So, you're going to get negative 5 plus 2 times a half. So what's that going to be? Negative 10 times a half. You're going to get y equal negative 5. So that's going to be your y-intercept. I do like to write it as a coordinate, so it's 0 for x, negative 5 for y. So that's done. The axis of symmetry, well, we can get that from the vertex. So we're going to go ahead and find the equation of the vertex. So I'm going to use this formula here. We've been using it for a while, but finally we've kind of written it down, you know, as a formula. It's really just an average. You're adding two things, dividing by 2, so it's an easy one to remember, and you also got your formula sheet. So I'm going to go ahead, I'm going to go 5 plus negative 2, so those are my two x-intercepts. going to divide by 2, so I'm going to get 3 over 2. And that will be the x value of vertex. X value of the vertex. I'm going to just shift that up. So now, if I want to find the y value of the vertex, all I got to do is plug it into my original equation here that I got factored. So to find the y value, I'm just going to label it y value of vertex. And I think somebody lost their Soothie. So here's my equation. So I'm just going to be plugging in 3 over 2 or a half. Kind of a pain. You know what, to be honest, you could use this, or you could use the original equation. Remember, they are equivalent, so it's sort of up to you which one you use. Just for the sake of plugging it into my calculator, I think I'm going to use this one here, which is the original equation. So here we go, just plugging it in. And then I would just go to my calculator, figure it out. So I'm just plugging in 3 over 2, which is the x value of the vertex. When I plug it into my calculator, I'm going to get y equals negative 6.125. There's no real need to change it into a fraction or anything, so you can just turn them both into decimals. So I'm going to write 3 over 2 negative 6.125. That's done. As far as the axis of symmetry, well, we can label this as well. This is the axis of symmetry. So we got everything there. Ta-da! Boom. 1 down. Let's go ahead and do example number 2. So this one here, we're sketching a quadratic function. If we're going to sketch it, we're going to need to know the x-intercepts if possible. So to sketch, we want to know the x-intercepts. Kind of losing focus here. Hang on. There we go. So you want to know the x-intercepts. Another good thing to know would be the y-intercept, the vertex, and really that should be enough. So we can go ahead, we can work on the x-intercepts. So that's going to just mean we're going to factor. And just looking ahead, to find the y-intercept, just going to plug in x equals 0. And to find the vertex, we can find the x value of the vertex by using this equation here. And then we can sub in to get the y value. So let's focus on the x-intercepts. This music is amazing. Looks to me like there's no greatest common factor I can pull out, so it is looking like a decomposition. If it is a decomposition, then we're looking at two numbers that multiply to 4 times negative 15, which I do believe is negative 60. I'm going to be looking for two numbers that add up to the b term, which is that one right there, so positive 4. So I'm pretty fast with this. I think my two numbers are 6 and 10 because they do multiply to 60. I need to make them multiply to negative 60 and add up to positive 4, so that's going to be pretty easy. If I go negative 6 times 10, then that is it's going to work. So I'm going to go ahead, I'm going to decomp. So I'm going to rewrite this. We're going to rewrite that b term. So I'm going to rewrite it as negative 6x plus 10x. So I always double check that's still equal to 4x, and then subtract 15. Okay, so now I'm just looking at the first two terms here. I'm looking at what can I pull out, what's the greatest common factor. Looks like it's going to be 2x. And I'm going to get 2x minus 3. Looking at the last two factors, looks like I can pull out a 5. So I'm going to pull out a positive 5. Going to get 2x minus 3. So these two brackets are the same, so we're just about done. Going to grab the two outside factors, 2x plus 5. Going to grab one of those brackets, 2x minus 3. We're done, it's factored. To get the x-intercepts, I'm just going to set each of these brackets equal to 0. And then I'm going to solve for x. So this one I'm going to get 3 over 2. This one I'm going to get negative 5 over 2. You can always go and plug those into your calculators to get a decimal value. I'm going to go ahead and throw those on my graph right away because I know I'm going to need them. So 3 over 2 is 1.5. So that would be right there. Negative 5 over 2, well, that's the same thing as negative 2.5. So I'm going to go to that spot and put a dot right there. I'm just kind of thinking ahead. I'm looking at the x squared term. It's positive, so I am expecting it to open up. At this point, it's going to be a really good thing to maybe say get the x value of my vertex. So let's go ahead and do that. So vertex, my x value, I'm going to use this formula. Going to plug in my two numbers. I already have a common denominator, so it's not really a big issue. I can go negative 5 plus 3. I'm going to get negative 2 over 2 divided by 2. So I'm just going to get negative 1 over 2. Then I'm going to get my y value. So honestly, most of the times to get the y value, it's probably just easier to go back to the original equation and just plug in what I got from my x value. So I got negative 1/2. So I'm going to be plugging that in. So this is one spot where your calculator can help you go a little faster. I think I already got a value written down here somewhere. Just need to find it. I got negative 16. Okay, so my vertex is negative 1/2. Negative 16. So I'm going to go throw that on my graph right away. So here's my graph. To make this easy, I'm just going to go down by negative 2's. So I'm just going to start labeling that. So negative 2, 4, 6, 8, 10, 12, 14, 16, and then negative 1/2 for x. So we're just over there. Technically, that is enough to get a sketch of the graph. Just for fun though, just for giggles, let's get our y-intercept. So that means that x equals 0, so that won't take very long. Again, I'm going to go back to the original quadratic that I was given. Going to plug in x equals 0. Anywhere where there's an x, kind of overkill, but here I am writing it all out. So my first two terms are going to disappear. So that's going to go to 0, that's going to go to 0. I'm going to get y equal negative 15. So as a coordinate, that's 0, negative 15. And I'm going to go and I'm going to plug that in over here. So here's negative 15 and 0 for x. By symmetry, I know I'm going to have the same point over here. I got more than enough to sketch it. So I know it's opening up. Ooh, and that is a beautiful looking parabola. Look at that beautiful parabola. It's so nice. Woo! Another example done. Looks like there's a part B here. You know what? I'm going to leave this one as an exercise. So I will have my notes online, so I'm just going to write. Example 3. So this one here is a little bit, actually I don't know, I haven't read it. So what do we got? We got a function passing through a point, and it gives me the zeros of the function. So remember, zeros is a fancy way of saying x-intercepts. So I'm just going to write that out right away. I got the X-intercepts, and they are 1 and 7. So that's x equal 1, x equals 7. I guess they're asking me to write the equation of the graph in general form. Not sure why there's a grid here, but it's there anyways. I don't really need it, not if I'm a pre-calc student. So if you look on your formula sheet, you do have this version of the quadratic equation. So basically it's just the factored form. So you guys worked on this whole last unit. Sometimes when you factor something, you get x minus a number, and x, minus another number. So basically what we can do is we can plug in these two numbers here and then solve for a. So I'm going to just plug in 1 and 7 in no particular order. Ooh, I forgot my a term. I meant to do that. I thought that looks really nice over there. It looks artistic. There we go. So I'm just plugging in the 1 in the first set of brackets. The signs will take care of themselves with this equation. So if you were to work backwards, use the zero product property and solve for your x-intercept here, you would get x equal 1, x equals 7. So that's all great. So they gave us a point B, and they told us that the graph passes through that point. So that is an xy value. So I can plug that in for x and y. I can solve for a. This is actually a pretty straightforward problem. Yeah, see, I just, that I did that on purpose again. It looks nice. There's like some symmetry going on here. So I'm going back to this equation. I'm plugging in 3 and 16. So 16 for y. I'm solving for a. There we go. So this should be pretty straightforward. I sure hope that Nico doesn't poop. That would make this question a lot harder. 3 minus 7, that gives me negative 4. So I get negative 8 times a. That's equal to 16. So easy enough. A is negative 2. I can now go ahead and finish writing my equation. Oh, Nico, no. Don't cry. There it is. I'm done. I think. I'm just going to read the question one more time to make sure. It says in general form. So, yeah, I'm not done. This is not general form. If you check your formula sheet, this is factored form. They want it in general form. So be careful. General form is not standard form. It's general form. This is general form. General form is the one where it looks like this. So it's the one from the last unit. It's our quadratic. So to do that, it's really easy. Just foil this out. Yeah, that's not so bad. Just foil it out, and everything will be fine. Nico's crying. I have to fix that. So here I go, foiling it out. That just means that I'm going to go ahead and I'm going to distribute the x into the brackets, and then I'm going to distribute the negative 1 into the brackets. Negative 2, I would just leave it outside for now. So here I go. Opening a bracket, going to get x squared minus 7x minus 1x plus 7. Going to do two things this time. I'm going to group my like terms, and I'm going to distribute the negative 2 into the brackets. So stick with me. I'm going to go negative 2 times x squared, which gives me negative 2x squared. These two terms here give me negative 8x. So when I multiply by negative 2, I'm going to get positive 16x. And then the 7 times the negative 2 gives me negative 14. There. Now I have it in general form. Hooray! So that is awesome. Let's give us a smiley face. Last question. So, it's, you know what, it's about time that we do the word problems here. So, we got a bridge that's spanning a horizontal distance of 40 meters. So, I've kind of already started the graph for us. If it's spanning 40 meters, if you start at 0, 0 and go to 40, 0, that would be a horizontal distance because we're on the x axis. That is from 0 to 40, so that's 40 meters. That is beautiful. It says 1 meter from the end of the bridge, the arch is 1.95 meters high. Okay, so because these things are symmetrical, it doesn't really matter where we put that point. You know, I don't know what the scale is here. I guess I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's broken up into 10. So each square, I suppose, is technically worth 4. You know, just for the sake of drawing this thing, I need some kind of a rough sketch. So I'm just going to label this point. I know it's not correct here, but I'm going to label that as 1, 1.95. So they're saying that 1 meter from the edge, the parabola or the arch is 1.95 meters high. So I know that I'm going to have some sort of a parabola that looks like this. Okay, over here that's going to be the same point. I guess it's not 1 unit, but 1 meter in, so I suppose this would be 39. Oh, Nico. Okay, I'm back. So 1 meter in from the edge, so that would be 39 for X. We are 1.95 meters off the ground. What are they asking me? They're saying determine the equation that represents the arch. So I have my X-intercepts, which are actually on the ground. So I'm going to need to know what is that vertex. So that is an X, Y value. So because I have the X-intercepts, I would probably be pretty wise to use the factored form of the equation and plug in what I know. So this is actually really nice because my X-intercepts are 0 and 40. So this is going to get really easy because it looks like one of my brackets I'm plugging in a 0. The other one I'm plugging in a 40. So that's great. X minus 0, no need to write it that way. I can just write A times X. So there I am. Now, gonna need to solve for this A term. So I need to plug in one of the X values. So I know this X value here, 1 and 1.95, so I'm going to substitute that in and solve for A. I could use this one over here, but I mean, I don't want to plug in 39, that's ugly. Or maybe, no, I don't want to plug in 39. I don't care. I'm plugging in this point here. This needs to end. So just reminding you, it's an XY point, so I'm going to plug in for Y. And for X, yes, I definitely don't regret plugging in 1. So I'm just gonna get, let's see, 1 times A, so A, and then 1 minus 40 gives me negative 39. So I'm gonna get negative 39 times A. I am going to, yeah, it's ugly, I know, whatever. I'm gonna plug in, or sorry, I'm going to divide both sides by negative 39. So when you do that, when you go, I better write this out because this is serious business. You know, in a word problem, the numbers often aren't going to be pretty, and you know, deal with it. Plug this in on your calculator, and we are actually being nice to you because you're going to get that. It's not that ugly of a number. So you have your A term. So I can finally write out my equation. Nico is getting very excited. Hey, little guy. Oh my god. You know, he just spit out his smoothie, so I'm not bad. Hey, I'm back. What are we doing here? Yes, so, in part A, they were just asking us for an equation. They didn't specify a format. This is an equation. So I would leave it at that. To do part B here, so there's my equation. To do part B, how high is the arch over the bridge? So basically that is a fancy way of saying what is the y value of the vertex. Because it's a parabola that's opening down, it's going to be a maximum. So it makes sense to me, should make sense to you. He goes crying. So that seems like a pretty easy one to me. Basically I need to find my vertex. So I'm going to find the x value of the vertex. Because I have my x-intercepts 0 and 40. So I'm going to get 20. Now that I have that, I can plug that into my equation here. From before, not going to rewrite it. So plugging it into my equation that I had from part A, when you work it out, which I trust that you can do, you're gonna get your answer. I'm gonna show you one step. So when you evaluate the brackets, you should get, I guess, negative 20 times negative 20, so you're gonna get negative 400. That's good, because I was kind of worried about that negative. It wouldn't make sense, because I can clearly see in my picture that it's not negative. So negative times a negative is positive, and when you evaluate that, you're going to get positive 20. So what is the height of the arch at the center of the bridge? Well, 20 meters. How do you spell bridge? Yeah.
You want the smoothest lounge tunes? Nice. Addict Radio Lounge.
That's pretty high. Wow. Alright.